Tank vehicles are a necessity for delivering a wide variety of materials to consumers and to industry. These materials include gasoline, fuel oil, a wide variety of chemicals, liquefied petroleum gas, aircraft and rocket fuels, milk, compressed gases, and asphalt. In the event of a tank vehicle fire, the danger to the firefighter can vary from none, in the case of milk, to an extreme hazard in the case of some chemicals. So a visit with your local tank vehicle operators to familiarize yourself with design features of tank vehicles is important. NFPA standards require that flammable liquid tank vehicles have internal emergency valves that are opened and closed by a lever. While the vehicle is in transit, these valves are always kept closed. The internal valve is protected by a shear section, which, in case of an accident damaging the piping, will break at this point, leaving the valve undamaged and preventing the contents of the vehicle from flowing out. This valve also can be shut by a secondary or remote control, normally located at the front of the cargo tank. These secondary controls operate by releasing a spring or by releasing air or hydraulic pressure. The required fusible devices, which automatically close the internal valves in case of fire, may be located either on the operating control mechanism in the cabinet or near the internal valve. The cabinet door on this tank vehicle is designed to close the control valves when the door is shut. Emergency relief venting for fire exposure is frequently in the dome cover and may be spring operated or can incorporate fusible plugs as shown here. Breathing vents for pressure or vacuum during normal operations are also located in the dome covers. Fusible plugs may also be placed at the top of the shell of the cargo tank. Reactive chemicals transported in tank vehicles may present severe fire and explosion hazards to you, the firefighter. Many of these chemicals may be extremely toxic. Here is an example of a mildly heat-reactive material. The container on the left is half filled with styrene, and for comparison, the one on the right contains an equal amount of gasoline. Notice how the heat causes a chemical reaction which expels liquid styrene from the container on the left. Triethyl aluminum ignites spontaneously with air, and as you will see, is violently water reactive. Every fire department should have these NFPA publications for information on reactivity and fire hazard properties of chemicals. Our first example of the types of fires you may come up against is at loading racks. These fires usually involve gasoline, which is the fuel here. But regardless of the fuel, the attack procedures are the same. Use straight streams first for cooling while maintaining a reasonably safe distance. Look for signs of reactivity or pressure buildup. Shutting off the fuel feeding a fire is always a primary consideration. Here the tank valves are closed, which stops the flow to the loading rack. When the flow of fuel stops, the attack slowly continues. Use narrow spray patterns to flush the burning gasoline from under the vehicle. Notice how the officer maintains control of the lines by keeping his hands on the shoulders of the nozzle men. The following backup line provides protection in case of a line break or other accident. The men stay on the inside of the attack lines to gain maximum protection from the spray pattern. As increased protection becomes necessary, the pattern is widened at the discretion of the officer. The cooling and flushing action continues until the burning gasoline is flushed away from the tank vehicle. When this is accomplished, the remaining fires to concentrate on are at the tires and at the dome. Approach the tires first, leave the backup line to continue the flushing, and move the other two lines slowly around the truck to extinguish the tire fires on that side. Do this carefully because the burning tires could ignite any gasoline vapors from a leak or some other source. When the officer is certain the tire fires are extinguished, the two lines are brought back around the truck. A man is sent for a pike pole and an extinguisher to put out the dome fire. The lines are carefully positioned to maintain overlapping spray patterns. The officer carefully goes up on the loading rack. The pike pole is used to close the dome covers, which in this case extinguish the fires. Officers should carefully check the dome covers for any remaining fires before leaving the loading rack. A slow, careful retreat is made, taking the same precautions as when attacking the fire. The purpose of this careful retreat is to protect against any possible reflash. The remaining fire, which was flushed away from the truck, has been allowed to burn out. The retreat is continued out of the danger area, and the lines are shut down. Our second example concerns highway accidents. These are a special problem because usually the only water available is from tankers. However, even with this limited water, it may be possible to effect a rescue by using the same tactics shown before, this time using a single 1.5-inch line. With some fires, you may be able to accomplish both control and extinguishment. Move the initial line around to the side to cool the cargo tank. If available, bring a second line in to assist in flushing the burning gasoline and to extinguish the tire fire. As the second line moves into place, the first attack line is moved into position for flushing the burning gasoline away from the tank vehicle. With 100-gallon-a-minute discharge from each 1.5-inch line at 100 pounds nozzle pressure, the capacity of the tankers will limit how much time you have for effective firefighting. Here, it was possible to flush the burning liquid down the ditch and extinguish the tire fire. Continue the flushing action to move the burning gasoline away from the tank vehicle. Other firemen build a dam by shoveling dirt into the ditch. This prevents spreading the fire to possible exposures and is used effectively by many fire departments. Now for a third example, spills without a fire. They introduce severe hazard because the unseen vapors may be ignited. These vapors can be dissipated with water spray to protect exposure. In any situation, find out the contents, either from the bill of lading or from the driver whenever possible. This man is using a combustible gas indicator effectively to determine the extent of the hazardous vapor and also to find out when it is safe to continue. If you don't have an indicator, be very careful not to enter a vapor area. When it's safe, Shut off the leaking valves or plug the leaking hole under spray protection. The spray is dissipating the vapors and flushing the liquid. When you flush liquid into a sewer system, notify your sewage disposal plant immediately. If possible, build a temporary dam to help prevent the spread of liquid. This is an aluminum cargo tank, our fourth example. Aluminum alloys will melt at approximately 1200 degrees. Therefore, aluminum in the vapor space, which is not kept cool by the liquid in the cargo tank, will melt from the heat of the fire. This cargo tank has been rolled onto its side, and two undamaged compartments are filled with gasoline to the bottom of the manhole cover. The first attack is made from a safe distance, using at least one 2.5-inch line at 80 pounds nozzle pressure. Cooling the aluminum prevents the cargo tank from melting. After being assured there is no reactive chemical involved in the fire, the next company's in should slowly continue the attack using 2-inch-and-a-half lines, with another one for backup protection. Approach from the side of the cargo tank, but watch the dome covers for any signs of liquid release. Make the attack from this side to protect the exposed building. When in close to the cargo tank, be certain you have control. Now bring in a dry chemical extinguisher to put out the fire. Move the lines slowly around to the end of the cargo tank. Carefully position the spray patterns. The line on the right is discharging to the right of the opening. The spray pattern on the left will be changed to a narrow pattern and be directed over the cargo tank 3 seconds after the extinguisher is operated. It will then be discharging at full capacity. The reason for this pattern change is that the water spray would otherwise seriously affect the extinguishing capabilities of the dry chemical. The extinguisher is operated. The spray pattern is narrowed while the extinguishing agent puts out the fire. The pattern is widened again for maximum protection. Foam also has been used successfully by some fire departments for this final extinguishment. A careful retreat is then made to protect against any sudden reignition of the vapors, which, of course, are being given off from the gasoline still in the tank. A hole like the one at the top was burned through the next bulkhead, but water kept the shell intact. Our next case concerns service station fire. They occur when the underground tank is overfilled. 30 gallons of gasoline a minute are flowing in this fire. The attack is from the side to flush the fire away from the exposure. Use 1.5-inch lines, changing from straight streams to spray as the approach is made. The truck is cool. Burning gasoline flushed away from the truck. The gasoline is flowing into the street. In the meantime, the next companies in control the exposure hazard by skimming the burning gasoline vapors off the surface of the liquid. Note the angle of the spray pattern. To maintain this angle, the second man keeps the line low. The attack at the tank vehicle continues. The lines are being used to cool the cargo tank and also to flush the burning gasoline away from the truck and exposure. As control is established, the men move sideways to the end of the cargo tank to operate the secondary control, which will close the internal valves and stop the flow of fuel. The backout is made, continuing the flushing action until the fire burns out. Meanwhile, the lines controlling the gutter fire have been operating simultaneously. The burning gasoline vapors are pushed up the street away from exposures. The lines are brought into the street to push any burning gasoline up a driveway into a vacant lot or to keep it burning harmlessly in the street. One line is open to full spray pattern for protection, while the other remains in a narrow pattern to keep the burning gasoline from flowing down the gutter. When the fire burns out, the final mop-up is made. Unfortunately, not all tank vehicles are equipped with the secondary or remote control. Therefore, it may be necessary to close the manual control valve. As before, attack from the exposure side to cool the cargo tank and flush the burning gasoline away from the truck. Backup line stays in place to continue the flushing and cooling while the two main attack lines slowly move around the front end of the truck. Once the lines reach the other side and are controlling the fire, the officer signals for the backup line to move around to take its normal position. The lines slowly move in toward the valve box. Overlapping spray patterns are maintained. The backup line moves to the left side since the burning gasoline has flowed in that direction. When the officer assures himself that everything is set, he moves across to close the valve which stops the flow of fuel. The slow backup is made to continue the flushing until the remaining gasoline burns out. Our final example involves a wreck between a tank vehicle and an automobile. This situation may require a rescue attempt. At least 2.5-inch lines with backup protection make the attack to search the car for occupants. The approach is made from the side of the tank vehicle. Use straight streams, first switching from narrow spray for driving the fire away from the car to wide angle for maximum protection. No one is in the car, so the lines are backed out. The hole apparently has been punctured in the cargo tank, therefore it may be useless or too dangerous to fight this fire with hand lines, particularly if the tank contains certain chemicals. An unmanned monitor can be set to provide a water curtain to protect exposures from this extremely hazardous condition. In other situations, the monitor can be set to keep the truck cool and the pressure down. At any rate, the area up to 1/4 of a mile should be vacated in case there are reactive chemicals in the tank. Note the steam from the water cooling the hot metal. Also, note the force of the stream driving much of the fire away from the truck. When the contents have drained out, the final mop-up action can be taken. Since there is always danger of a reignition or possible explosion, be very careful. One line is sent to the other side of the truck to help extinguish the tire fires. The portable monitor stream is moved aside, but kept operating in case of sudden need. Mop-up action continues until all tire fires and any fire in the automobile are completely extinguished. The final extinguishment of any fire at the dome can be made with an extinguisher under spray protection. Now, let's review what we've seen. Remember, in all fires, determine the truck's contents, whether it is stable or heat reactive or water reactive. For your own safety, have these NFPA publications available to you so you will know the hazard properties of material. Know and remember the design features of various types of tank vehicles and relate them to firefighting. Even with a relative shortage of water, rescues can be made and limited firefighting accomplished. Always cool tanks with straight streams first. Approach the fire slowly and deliberately under spray protection. Stop flow of fuel by closing valves at the tank, at the truck, by plugging holes or by other means. You can control running fires in gutters and ditches. Always back out slowly. Protect against a reignition. Water spray will dissipate vapors. Incidents without fire are still dangerous because there might be an ignition of vapors. For fires that are useless or too dangerous to fight with hand lines, use monitors on the fire or as a water curtain. Then vacate the area. For more detailed information on handling tank vehicle incidents, the National Fire Protection Association has made available a full set of color slides for training. These 2x2 slides were taken during the filming of this picture. A written commentary for use by the instructor accompanies this set of slides.